Hello students, myself Borude Usha from MJS College Srigunda. Today we are going to see chapter number 6 from 12th science. The name of that is Superposition of Waves, and from that today we are going to see the amplitude of the resultant wave produced due to superposition of waves. So what is the exactly amplitude? When two or more waves, when traveling through a medium, arrive at a point, commonly at a point, then each wave produces its own displacement independent of the other. At that time, the resultant displacement is nothing but it is equal to vector sum of displacements of all the waves. This is called as a superposition of waves. Okay, so once again, listen carefully. What is superposition of waves? Superposition of when two or more waves traveling through a medium arrive at a point commonly, then that point each wave produces its own displacement independent of the other. At that point, the resultant displacement is equal to vector sum of all the displacements due to the waves. Okay, this is called as a superposition of waves. So what happened, or what is the value of amplitude when two waves interfere with each other, when they are in phase, when they are out of phase? So we are going to see that values in this case. So next one more, that is amplitude of the resultant wave. Next one more, amplitude of resultant wave produced due to superposition of two waves. Produced due to superposition of two waves. Consider the displacements of that waves. Okay, at x is equal to 0, then at that time, or consider amplitudes A1 and A2 are amplitudes. That means there is a little difference in amplitudes of two waves, but frequency is same. Suppose frequency is same, there is little change in their amplitude. So what are the values of the displacements of that waves? So at first, y1 is equal to a1 sine of omega t. This is equation number first. At x is equal to 0. Okay. Now another one, that is second one, y2 is equal to a2 sine of omega t plus psi. There is a difference of phase of psi in between these two displacements of waves. Equation number second. So what is the resultant displacement? By using superposition of waves, then the resultant displacement y is equal to y1 plus y2. Then which is equal to y is equal to, by adding these two equations, that is a1 sine of omega t plus a2 sine of omega t plus psi. Since psi is a phase difference. Okay. Now next one more, that is a1 sine of omega t. By using sine a plus b, by using sine of a plus B is equal to sin A cos B plus cos A sin B. By using this one formula, we will get plus, since here A2 sin omega t cos of psi, sin of omega t cos of psi plus A2 as it is, okay, cos of omega t plus sin of into sin of psi. Is it clear? Then take the common factor, that is sin of omega t, sin of omega t. Will remain here, that is A1 plus A2 cos of psi out of bracket sin of omega t plus A2 cos of omega t into sin of psi. Okay. So, nextly, consider that suppose this one A1 plus A2 cos of psi, which is equal to, suppose this is equal to A cos of theta, A cos of theta, and this A2 cos of omega t is equal to, A2 sin of psi, A2 sin of psi is equal to, suppose A sin of theta. This is equal to, suppose A cos of theta, and A2 sin of psi is equal to A sin of. Substituting this value in above equation, you will get y is equal to A cos of theta sin of omega t plus A cos of omega t sin of theta. So once again, this is cos theta sin of omega t, cos of omega t sin of theta. That means this is equal to A sin of omega t plus theta. So this is the equation of the resultant amplitude. Okay, this is equation of resultant wave, and it has the same frequency as that of the interfering waves. Okay, and the resultant amplitude is A, whose value is, we are going to find out now. So this is the resultant displacement of the wave when two waves interfere with each other. Afterwards, what's the value of amplitude? That means we are going to find out the value of amplitude. So for that purpose, consider these equations. That is, suppose this is equation number 3, this is equation number 4. Equation number 3 and equation number 4. Then squaring and adding equation number 3 and 4. What we will get? We will get A square, since squaring and adding, A square cos square theta plus A square sin square theta, which is equal to square of this plus square of this. Therefore, it is equal to A1 plus A2 cos of psi bracket square plus A2 square sin square psi. Okay? Squaring this, we will get A1 square plus twice A1 A2 cos square psi plus A2 square cos square psi plus this plus A2 square sin square psi. Okay, since this A2 square will take common. After that, cos square psi plus sin square psi is equal to 1. So what remains here? Here remains A1 square plus twice A1 A2 cos square psi plus A2 square. What is this? This is the square of A1 plus A2 cos psi plus a2 square cos square psi. Now it is clear. So what is here? Here is a square, okay, this is 1. Take a square common, into bracket this is equal to 1. Therefore, amplitude A, resultant amplitude A is equal to square root of A1 square plus twice A1 A2 cos of psi plus A2 square. Okay, now this is the value of the resultant amplitude. Now there are special cases. That means what? What's the value of psi? Depending on that, there is the maximum amplitude or minimum amplitude. When two waves are in phase, then that time there is the maximum amplitude. That means when psi is equal to 0. So special cases. First one is there. That is if psi is equal to 0. If psi is equal to 0, that means phase difference is equal to 0. Then what's the value of amplitude? That is nothing but A1 is equal to square root of A1 square plus twice A1 A2 cos of 0 plus A2 square. Okay. So what's the value of cos of 0? Since cos of 0 is equal to 1, we will get the value, that is square root of A1 square plus twice A1 A2 plus A2 square. That means this is nothing but A1 plus A2 bracket square raised to square. Therefore, totally A is equal to A1 plus A2. This is the value of the resultant amplitude and this is the maximum value. Maximum value. When phase difference is equal to 0, then amplitude is maximum. When A1 is equal to A2, when these amplitudes are same, is equal to A2, then A is equal to twice A. Then A is equal to twice A, or the resultant amplitude is equal to, we are going to say here, resultant amplitude is equal to A1 is equal to A2 is equal to A, then resultant amplitude is equal to twice A. Okay, this is the first case. Then second one, if psi is equal to pi, psi is equal to pi, right? Then what is the value of resultant amplitude? That is A is equal to square root of, since psi is equal to pi, cos of pi is equal to minus 1. Therefore, this one A1 square plus twice A1 A2 cos of psi plus A2 square. This will become, that is nothing but A1 square minus twice A1 A2 plus A2 square. That means it is equal to square root of A1 minus A2 bracket square, which is equal to A1 minus A2. Therefore, A is equal to A1 minus A2. When the phase difference is equal to pi. Okay, and this is equal to mod of A1 minus A2. Then when A1 is equal to A2 is equal to A, then the resultant amplitude is, if A1 is equal to A2 is equal to A, then resultant amplitude is equal to, resultant amplitude is equal to 0. Okay, A minus A, it will becomes 0 and it is minimum amplitude. When it is minimum amplitude, when the phase difference is of pi radian, then there is the minimum amplitude. When phase difference is of 0, that means when two waves are in phase, then there is the maximum amplitude. When two waves are out of phase, then there is minimum amplitude. These two special cases are Then, okay, intensities are directly proportional to the amplitude square. Therefore, intensity is directly proportional to amplitude square. We know that when it is maximum, that means intensity maximum is directly proportional to when that is it is a max bracket square. When it is possible when or it is equal to A1 plus A2 bracket square. Okay, so this is the intensity maximum. When it is possible, that is when psi is equal to 0. That means phase difference is equal to 0. Intensity minimum is directly proportional to amplitude minimum bracket square. That means it is equal to A1 minus A2 bracket square. When it is possible, when psi is equal to pi. Okay, so these are the values of intensity maximum and intensity minimum. Okay, therefore intensity is maximum when two waves are in phase, and intensity is minimum when these two waves are out of phase. So this is the amplitudes for the superposition of waves. Okay, consider the example. The displacements of two sinusoidal waves propagating through a string are given by two waves we had given. Y1 is equal to 4 sine of 20x minus 30t. Okay, and Y2 is equal to 4 sine of 25x minus 40t. Kx minus omega t. Sine of kx minus omega t च्या स्वरूपामध्ये. Therefore y2 is equal to this much. What they are given? Calculate the phase difference between these two waves. दोन्ही waves मधला phase difference किती आहे? केव्हा? At the points x is equal to 5 centimeter and t is equal to 2 seconds. And secondly, they had asked us find out maximum and minimum values of intensity. Okay, so first one, solution for that. Solution, that is here y1 at x is equal to 5 centimeter and t is equal to 2 seconds. Okay, so this one y1 becomes 4 sine of 20x minus 30t, which becomes 4 sine of 20 multiplied by 5 minus 30 multiplied by 2, which is equal to 4 sine of 100 minus 60. That is equal to 4 sine of 40. 100 minus 60, 40. Another one, y2, that is equal to this 4 sine of 25x minus 40t, which is equal to 4 sine of, substituting values of x and t. Okay, x value 5, so 25 5s are 125 minus 40 into t, 8t. Okay, so what's the value of this? This is equal to 4 sine of 125 minus 80, that is 45. What is the value of this? That is sine of 45 and sine of 40. So what is the phase difference in between them? That is equal to mod of 45 minus 40, which is equal to 5. Okay, so phase difference of this is equal to 5 radians. So mod of this phase difference in between them is 5 radians. Okay. Sine of psi. Psi is the phase difference. So 45 minus 40, that is equal to 5 radians. So phase difference of differ by 5 radians. Then next one, that is intensities. What's the value of intensities? Which is directly proportional to amplitude square. When it is maximum, intensity maximum is equal to A1 plus A2 bracket square. Intensity, that is A1 plus A2, where here A1 is equal to 4, A2 is equal to also 4. Therefore, it is equal to 4 plus 4 bracket square. That means it is equal to 4 plus 4, 8 bracket. That is 64. And intensity minimum, that is equal to A1 minus A2 bracket square. That means 4 minus 4 bracket square, which is equal to 0. So intensity maximum, that is equal to 64, whereas intensity minimum is equal to 0. Okay. So this phase difference, in this case, phase difference is of, in this case, phase difference is of pi radian, whereas here phase difference is 0 radian, 0 degree. Okay.